All right, let's start today's part. Today is basically the third day for the training session of Stata 15, and we are going to consider some of the parts that we have left yesterday. Uh, we have covered so far uh, the basic environment and layout familiarity. We had covered some part of the data management yesterday and in session two, in second day session. Today is third day, so we will cover the remaining part of data management, and we also try to cover the graphical visualization completely. Then tomorrow, descriptive statistic, mean comparison, correlation, association in the coming session. So let's start what we have left yesterday. We are basically doing basic data management. We have discussed the describe command, the code book. We have discussed the list and tabulate command, tabulate one, and so on. We are having a lot of commands there, and we have covered only a specific part of tomorrow's session. So let's suppose we are starting from tabulate command. Here you can see the tabulate command, and it requires you to have two of the variable, like you would like to tabulate foreign in terms of mpg. So we will replace two different variables from here. Let's suppose this is the Stata version, this is our data set, and we have a lot of variables here. So let's suppose I would like to tabulate Tobin's Q. I just need to write tabulate or simply tab. You can write also tab. That is a short word of tabulation, and you can write the variable to which you want to tabulate. Just click enter, and you will see uh, the tabulation of your variable. It will indicate the number of observation in that particular variable, like which word is uh, repeating again and again. You can see here uh, there is a value which is uh, 0.32. It is repeating three times. There is a value of 0.374. It is repeating two times. There is a value of 0.377. It is repeating two times. So it will indicate your data, that how much your data is basically scattered, or how much your data is basically you can generate. So you can also generate different types of variables. From generate command, you just need to write gen. You don't need to write the complete command. You can write the complete command, but the gen is the short word for generating a variable. So how can you generate a variable? For example, I would like to generate Tobin's Q2. Let's have Tobin's Q. Just click on it, and I would like to create Tobin's Q2. So how can I create it? I need to write the Tobin's Q, and then for multiplication, I can use the steric sign, multiply by 2. So it will generate Tobin's Q, which is basically the multiplication of Tobin's with 2. So you can see on the right side that there is a Tobin's Q generated here. So for example, I would like to generate another variable, like I would like to generate the half of the leverage, half leverage. So leverage half. This is the name of the variable. The first part indicates the name of the variable, then equal sign. Then you need to provide the formula that how you can calculate this new variable. So I want half of the leverage. So how can I conduct the half? I need to put the actual variable, then I need to put the slash sign, then I need to put 2. It estimate the half of that variable. So I click enter, and you can see that leverage half would be indicated here. So in the same way, you can generate different variable from the existing set of variables. Even you can create the square root of different variable. For example, I would like to generate another variable, which is the square, which is the square root of thumb size. Let's go. I want to generate square root of the firm size. So how can I generate it? You need to put equal sign. You need to put SQRT, which is basically a short abbreviation for square root. SQRT. Then you need to put a bracket, and within the bracket you need to put your variable like this. Now it will square root your variable, and it will indicate square root f size. So just press enter, and you will see a variable here. And if you want to check the values of these new generated variables, you just need to go to the data editor bar here, and just horizontally scroll right side, and you can see uh, the new generated variables here, like Tobin's Q to leverage half and square root of size here. So these are basically newly generated variables with the help of existing variables. So is it clear to both of you? Can we proceed further?
Yes.
All right. So this is how we can use. I will provide this file after making some edits, and I will let you know the complete list of all the commands that we are going to use. Like here is the command save, auto, replace, and so on. I will edit these commands. So let me check. These are all related uh, to the same category of command. So I will share the complete list of these commands so that you can practice. So this was all about the data management that we have covered. Now I would like to discuss the graphical visualization, how we can conduct different graphs, how can we conduct different graphs using our data. Sometimes you see line graph, bar charts, and so on. So how can we generate those graphs? I have created a list with the real time data that we can use using the same data set. It is basically a corporate governance data set. One thing I would like to let you know, let's suppose I have generated some of the variable. So let's suppose I want to drop some variable from these set of variables. Like I would like to drop Tobin's square to this variable, or this variable, or this variable. So how can I delete this variable? There are many ways you can do it. You just simply click on a particular variable that you would like to delete. Just right click on it, and it will show you some options like drop selected variable. You can click on it, and it will ask you whether you would like to drop this variable. Yes. The other method is to write drop, the word drop, and then the variable you would like to drop, like leverage half. uh, I click on it, it will appear here, and I just need to click enter, and it will drop the particular variable from here. So there are two methods. One is just simply click on the variable, right click, and drop that variable. So it will ask you to drop the variable, and you need to click on yes. So these are some basic commands that you can use uh, with the data management. So let's start the data visualization part for today. I have prepared this slide for day 3. Yes, this one. Today we are going to discuss the third part, or third day training session dated 7th March 2024, 6:20 to 7:40 p.m. We have discussed basic environment and layout familiarity. We have also discussed the data management, different commands using how to change your data, how to uh, find out different types of tables or formats. Today we are going to discuss the graphical visualization, how we can generate different types of graph. And from tomorrow, our more complex part will be starting. Descriptive statistic, mean comparison, correlation, regression, and so on. So our focus for today is on graphical visualization. How can we create graphs? So what are the graphs? There are different graphs here, like histogram, box plot, and so on. So I would like to discuss some important graphs from here, and we need to see what type of graph we can generate. The first graph or first basic graph that we need to use is the histogram, and you just need to write histogram and then the variable name that you would like to find out the histogram for. So let's suppose I write here histogram, HISTOGRAM, histogram. And then I need to write the name of the variable for which I need to create a histogram. For example, uh, I would like to see font size histogram. You just need to click font size here, go here and click enter. And you will see a histogram like this. This is a histogram of font size. If you want to copy this particular graph into your output sheet, you just need to click on it and go to the edit. And from here, you just need to select copy. The other way is that you need to right click on it and you need to click copy. You can also save this graph as a picture. Like for example, if I select save as, I go I go to locate it on some options, like for example, I would like to locate it on desktop. I can rename it like histogram. It will show in my location where I have saved it. You can you can see here. You can refresh the page, and here it is. It is with the name of histogram. You can open it. If there is no app here, you just need to copy. If there is a app which can display the picture, you can use that app. But if the app is not available, you just need to copy. You need to copy from here, and you just need to put it into your Word file. Click Control V from your keyboard, and it will put like this. Now you can write here histogram size. So this output is generated with the help of Stata. This is the first output. You can create output of any variable. You just need to repeat the same command here, and you just need to put the name of any variable. For example, with the histogram, I would write ROA. I need the histogram of ROA. I just need to put here, along with the histogram, I need to put the variable name as a ROA. It will generate the histogram of my variable. Then right click on it, copy it, and paste it wherever you would like to show this graph, like this. You can generate the histogram of any option. The next graph I would like to let you know is graph box. What is it? It is, and how you can prepare it, and what does it do? The graph box command can be used to produce a box plot. Have you heard about the box plot, that it indicates the normality of the data? Some of the researchers use box plot for indicating whether the data of a particular variable is normally distributed or not. So it can help you examine the distribution of variable. Bell-shaped distribution and something like this. So if a target variable were normally distributed or not, or it is giving the line median line or the middle line, whether it is giving you 25th percentile or 75th percentile or Q1 or Q3, I will let you know what are these terms. So the command is basically the graph box and then the variable name. So you need to put graph box and then variable name. This is the command. So I would write here graph box and then I need to put variable name. So let's suppose I would like to graph box ROA. I just need to click here from this sign ROA and just need to enter, and you will see a picture like this. This is a box plot, and you have you are seeing some of the points here, which is beyond these two lines. First of all, I would like to let you know that the first line here is basically the first quartile. It means 25th percent of your data points are laying here. This is basically the middle quartile. Your data should be in the middle of these quartiles. This is basically the third quartile, and this is the fourth part. So whenever you see some data points which are beyond the first line and the last line, it means there are some you can say outliers in your data. So in our case, there are some outliers. So these points should not be here. So it will indicate that there are some outliers here. So how can we remove these outliers? I have also mentioned here. Box plot can be done separately if there are a pair of outliers in the box plot produced. These can be removed from the box plot by using no out command. You just need to add a no out command with your previous command, no out. Let's suppose this was my first command that I was using for generating the box plot. I need to add a comma and that and then no out. This is additional feature that will eliminate the outliers from your particular variable data box. So just add comma and then add no out and center, and it will generate the box plot like this. Now this is error free, and this is also normally distributed. You can see there is no any dot which is uh, 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 below the first line and below the last line. uh, Again, I would like to let you know that this first line from the bottom side, this is the first quartile. Any data points between this first line and this second line are considered as quartile 1 or Q1 or 25th percentile. Any data points between this second line and between third line are considered as a second quartile. And this middle line is considered as the median of your data. So it indicates that your data is normally distributed. So whenever this line is places in the middle of your data, it means your data is normally distributed. Then the distance from this line to next line is considered as a third quartile. This area is known as third quartile. Then from your third line to fourth line, this area is called fourth quartile. So always remember that whenever you see any data point beyond your fourth line and below your first line, it means they are basically the outliers that should be removed. So using this plot, you have removed your data points. Now you can report this as an output of your main file if you would like to. So this is a box plot of ROH. It is normally because it is indicating, yeah, that your data is normally distributed. There is no outlier here, and the middle line is in between your data points. There are four data points, and you are seeing that uh, this particular box plot is appearing on the middle of your data points. So this is normally distributed. You can also check the same for other graphs also. Like previously, I have used this graph box for ROA. Now I can use the graph box for toggle skew. Let's suppose I put here toggle skew, and let me check whether it also includes, yes, it also includes outliers. You can see here there are a lot of data points which are beyond fourth line. So these are the outliers, and you can remove it. How can you remove it? Just to add not out command with your basic command. So put your command again here, and add a comma, then write no out. This is the command which will eliminate the outliers from your box plot. So enter, and you will see a box plot like this. So you can see here there is some normality issue here because most of the points are in fourth quartile. It is indicating that most of the points lies between 2 and 4, because this area is much wider than third quartile, then second quartile, then first quartile. So there are more points in fourth quartile than on second or first or third quartile. So this may not be a mean, sorry, this may not be normally distributed graph because it is not in the middle side. If you copy it and if you compare it with your previous picture, the previous picture was indicating an equal distribution of data points between all parts. So here we can put it, yes, this one, and this is the box plot for. So I hope you have understand the box plotting procedure. We can go further. There are a lot of other options here, but that options require that you should have a categorical variable. In our case, if we would like to check whether we have a categorical variable or not, we can check it from the code book. And you can check the code book whether you have some categorical variable or not, because the other command requires you to have a categorical variable. This is continuous, this is also continuous. We need to check all the variables are continuous here. There is no variable with categorical units. So whenever we might have some categorical variable with us, we can use this particular command. So what does this command actually do? Just read, just we just need to read it. I want to remind you that there is less than 1 minute remaining to end the meeting. If the meeting ends, use the same link